Okay, lesson 6.1, solve systems of equations by graphing. We are on page 319. Okay, so two or more equations with the same set of variables are called a system of equations. So if I look down here, right here, and right here, I have two different equations. Because there are two different equations that are together, we call them a system of equations. Call them a system of equations. Okay, now the solution of the system is this point, because that's the ordered pair that is the solution or the answer for both of these equations. It has to be true for both of the equations. So how do we check it? Well, remember this is the x value, this is the y value. If I take the y value and I plug it in here, so that would be 50. And then 10, I plug it in for the x. We're going to see if it's true. Now, if you look right here, do you see it has a question mark? Because we don't know if it's true or not yet. We don't know if they're equal yet. So we're putting a little question mark, asking ourselves, is this going to be true? So 50, and then 5 times 10 is 50. So yes, it does work. So that is a solution for y equals 5x. But now we have to check and make sure that it's a solution for the other equation. So now I'm going to do the exact same thing. I'm going to take this y value and I'm going to plug it in here. That's 50. I'm going to take this x value and I'm going to plug it in here. And then I'm going to solve it. Well, I'm actually going to do this. 2 times 10 is 20 plus 30. That does give me 50. Since both of these came out to be true statements, since both of these are a true statement, it came out true here, it came out true here, that means it is a solution. The solution for this system will be 10, 50. Okay? So then we're going to look here. It says you can estimate the solution of a system of equations by graphing the equations on the same coordinate plane. The ordered pair for, that's very important. The ordered pair for the point of intersection of the graphs is the solution of the system. So where they run into each other. So in this graph that's shown here, they intersect right here only at one point. They only run into each other at one point. And that system has one solution. Okay, so this has one solution. And what is that solution? That solution is 10, 50. Okay, so we're going to look at this, and we've got to be able to graph our lines. So if I look at this first one, the slope of this one is -2. Remember, that's -2/1. And the b value is -3, or the point 0, -3. So I'm going to go to 0, -3, and I'm going to plot a point. Remember, since it has a negative slope, it's going to go this direction. Just for right now, I'm going to actually go up to, I'm going to show my going up to. And remember, it's going downward, so I have to go to the left. So I'm going to plot that point. Okay. Then I'm going to go up 2 again. And I'm going to go to the left 1. I'm going to plot my point. I'm going to go up 2 again. Go to the left. I'm going to go up 2. I'm going to go to the left. 1. Now, I could have also, from the y-intercept, gone down 2 and to the right 1, like so. And then I draw my line. Now, you really don't need showing going up and over. I just did that so that it was easier for you to see. Then I'm going to use this one. On this one, my slope is 2, or 2 over 1. My y-intercept is 5. Oh, I really didn't want to use that color. How about we do this? Nope, I don't want that color either. We'll do pink. The reason I didn't want to is because up and over uses those colors. That's why. So my y-intercept is 5. So 1, 2, 3, 4, 5. My slope on this says that it's going to go up. Well, at this point, I can't actually go up. So I'm going to go down 2, but I still need it to be a positive slope. So if I go down, I need to go to the left. And I plot a point. And if I go down 2, I go to the left. I go down 2, I go to the left. I go down 2, and I go to the left. I go down 2, and I go to the left. And then I plot my points. Oops, I forgot that point. And I'm going to get rid of these colored things. Maybe can't get rid of all of them, but that's okay. Okay, so now to find the solution, I want to know where the two lines intersect. They intersect at this point right now, or right there. So I need to name that point. And that point is going to be the point I go over 1, 2. So that's -2. And it went up 1. So it's the point -2, 1. Making sure that you have parentheses around it. Now we need to check and make sure that it is true. So we're going to plug those numbers in. So we're going to replace x with -2. So right here and right here, we're going to replace x with -2. They did it right there. And then we're going to replace y with 1. So right here, they replaced y with 1. Now we're going to see if it comes out to be correct. So if I look at this right here, -2 times -2 gets me 4 minus 3. So I have a 1 here. Does 4 minus, that gets me 1. So that one works. So it is a solution for this. Yes, it is a solution for that one. Now we have to check this one and make sure it's a solution over here. So I have 1, 2 times -2 gets -4 plus 5. 1. What's -4 plus 5? 1. It works. So it's a solution for this one. Since it's a solution for both of them, it is a solution to the system. It has to be a solution for both of them for it to work. Okay, so I'm going to come here. I'm going to do the same thing that I just did. And here, my slope, the number in front of x is 4, which is the same thing as 4 over 1. That's a positive slope, so it's going to go this direction. The y-intercept for this one, the b value, well, what's added to that? Nothing. So nothing would be 0 because that is a proportional relationship. So I'm going to go to 0. I'm going to go up 4. So 1, 2, 3, 4. And I'm going to go to the right one so that it's positive. Or I could have, from the origin, gone down 4 and to the left 1, oops, sorry about that, and plotted a point. And voila. Then I'm going to look at this one. M equals, the invisible number that's right here is not 0. There is an invisible 1 right there. 1, which is 1 over 1. The B value is 3. So I go up to 3. 1, 2, 3. I plot a point. Okay, the direction of this line is also going to be positive. So I'm going to go up 1 and over 1, up 1 and over 1. I could have gone down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Go like so. Okay, so the point where these two intersect, this is a 1, so that's 1 comma, and we went up 1, 2, 3, 4. Now we have to make sure that it actually works. So I'm going to say y equals, oh, you know what? Let me do this one in blue. Y equals 4x. So I'm going to replace the y with 4. I'm going to replace the x with 1. 4 equals 4. So this one works, so it is the solution for that one. So now let's try the other equation. Y equals x plus 3. So I'm going to replace the x with 1, the y with 4. So 4, does that equal 1 plus 3? It does equal, so this is the solution. So the answer to that question is the point 1, 4. Okay, so let's remember, on this one, anytime you have x equals a number, you are going to have a vertical line. Anytime you have y equals a number, you are going to have a horizontal line. So if I have x equals 3, I'm going to go over to 1, 2, 3. When x equals 3, x equals 3 all along this right here. Every single one of these points has an x value of 3. So it is a vertical line through that point. I go to y is negative 6. So this is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. And all of this, the y value, is negative 6. So what is the point where they run into each other? 3, negative 6. So you check your work. Look at this. Does x equal 3? It sure does. Does y equal negative 6? It sure does. Since x is equal to 3 and y is equal to negative 6, the solution is 3, negative 6. So I do this again. Remembering that when x equals a number, I'm going to have a vertical line. When y equals a number, I'm going to have a horizontal line. So x is equal to negative 1. Negative 1 is here, so that means I'm going to have a vertical line. I go to when y is negative 4, so that's negative 1, negative 2, negative 3, negative 4, and I will have a horizontal line. The point where they run into each other, negative 1, negative 4. Okay. If a linear equation is not in slope-intercept form, you can use the properties of equality to rewrite the equation. Okay. So if I want to get y by itself, that means I need to get rid of this 4x. So the opposite of a 4x is a negative 4x. So I'm going to subtract 4x from both sides. This right here will cancel out. I bring this straight down, and I have 16 minus 4x. Now, I want y equals, not 2y equals. That's multiplication, so I'm going to divide both sides by 2. 16 divided by 2 is 8. Negative 4x divided by 2 is negative 2x. Now, you want it in y equals mx plus b, so you're just going to rewrite it so it looks like this. Okay? So, over here, some systems of equation have no solution. Okay? If the graphs of the lines are parallel, they're parallel and therefore never intersect, then there is no solution. Okay? In the graph shown, there is blank intersection points. Do they ever hit each other? No, there are 0 intersection, and the system has 0 solution or no solution. Now, before I go on, I want to do something here. What is the slope of this line? 2. What is the slope of this line? 2. Notice how they have the exact same slope. Okay, solve the system of equations by graphing. Check the solution. Okay, so this one is in y equals mx plus b form, so we're safe. The second one, though, the second one is not in y equals mx plus b form, so we need to make it that way. So I need to get this to the other side of the equal sign. So the opposite of subtracting would be adding. So I'm going to add 2/3 x to the other side. I'm going to add 2/3 x to the other side. Now, why they write it this way instead of just writing 2/3 x minus 3, I don't know. But they don't. Okay, so now I have these two equations. We just solved them. So if I look at this first one, the slope is 2/3. My y-intercept is 1. So I go to 1. I'm going to go up 2. I'm going to go to the right 3. Why did I go to the right? Because this slope is positive, so it's going that direction. So I'm going to plot my point. I can't go up 2 over 3, so I'm going to go from the y-intercept, I'm going to go down 2. I'm going to go over 3. 1, 2, 3. And plot my point. Okay. Okay. Now I'm going to go to this one. It has a slope of 2/3 also. It has a y-intercept of -3. It's still positive, so it's going to go this direction. So I'll go down to -3. 1, 2, 3. And I plot I go up 2, I go over 3, and plot a point. Or I could have gone down 2 and over 3 and plotted a point. This is why I like to get rid of the up and overs because they get confusing. Okay, so do they ever run into each other? No, they don't. So no solution. If you look at it, they have the same exact slope. So they have the same slope. And this right here, they have a different y-intercept. Okay, So we plug it in. Oh no, sorry. No, we're not. We're gonna do this. Okay. So this one, I have y minus 2x equals 4. I need the y to be by itself, so this minus 2x needs to move. So I'm going to add 2x to the other side of the equal sign. Y equals 2x plus 4. So my slope on this is 2. My y-intercept on this is 4. So I go to 4. Okay, my slope is going to be positive. I can't go up 2 because there's nowhere to go, so I'm going to go down 2. But remember, it has to be a positive slope. So if I went down, that means I have to go to the left. Okay, so I'm going to go down 2, but I'm going to go to the left 1. Okay, so I'm going to go down 2. I'm going to go to the left 1. I'm going to go down 2. I'm going to go to the left 1. When I do that, and I'm going to get rid of these because they get in the way. Then I'm going to look at this one. This has a slope of 2. It has a y-intercept of 0 because there's nothing added to it. Again, that's a positive slope. 2 is the same thing as 2 over 1. So I go to 0, 0. I go up 2 over 1. I go up 2. I go over 1. Or I could have gone down from the y-intercept. So I go down 2. I go over 1. I go down 2. I go over 1. Plot my points. Okay. And I don't need, this one will be hard. Oops. Undo. May not be able to get a couple of those little lines. Okay. So what is their solution? No solution because these lines are parallel. Okay. Now, some systems of equation have infinitely many solutions. If the graphs of the lines are the same, therefore they intersect at every point. That gives them an infinite number of solutions. So this equation right here and this equation right here are actually the exact same point. So in the graph shown, the lines intersect at every point. The system has infinite. And some of you are like, that's not the same equation, they're different. Well, let's prove that they are the same. I want y by itself, so that means I have to get rid of this right here. So that says minus 3x. So I'm going to add 3x to the other side of the equal sign. When I do that, this goes away. I have y equals 3x plus 5. And that is the exact same equation as that one right there. Okay, so let's look at these. This first one is in y equals mx plus b form, so we're safe. This one, however, is not. That needs this negative 3 to move to the other side. So we're going to add 3 to both sides of the equal sign. That means this right here turns to 0. It goes bye-bye. 2x stays the same because we didn't add anything with an x. Now we have 3 minus 2, which is 1. Now, This right here is y equals 2x plus 1. So my slope on this is 2. My y-intercept is 1. It's going in the, remember that's over 1. So I go 0, 1, up 2 over 1, up 2 over 1, or down 2 over 1, down 2 over 1, down 2 over 1, making sure that it's a positive slope. And if you look at it, isn't that the exact same equation? So that means that we have infinite solutions. Okay, infinite number of solutions is the answer to this one. Okay, so on this one, right here I have y plus 1/3 x equals 1. But I need it so this right here moves to the other side. So I'm going to subtract 1/3 x. And I'm going to get y equals negative 1/3 x plus 1. If you notice, both of these equations are exactly the same. They have the same slope and the same y-intercept. Okay, my slope here is negative 1/3. Oh, that's negative direction. And my b value is 1. So I go to, my b value is 1. I go down 1. I go to the right 3. And I plot a point. Okay, I can't go down 1 and over 3 there, so I'm going to go back to my y-intercept, and I'm going to go up 1, but to the left 3, because I need this to go in the negative direction. And voila. Okay, the Spanish Club is having a bake sale. You can buy a bag of trail mix and a loaf of pumpkin bread for $11, or 3 bags of trail mix and 2 loaves of pumpkin bread for $24. This situation can be represented by the system of equations of this right here. Okay, so let's think of it. Oh no, I'm not even going to talk about it quite yet. And this equation right here, where x represents the bag of trail mix. Okay, so x is the cost of a bag of trail mix, and y represents the cost of a loaf of pumpkin bread. Okay, how much does each bag of trail mix and each loaf of pumpkin bread cost? Okay, I want us to look at something real quick. You can buy a bag of trail mix. How many bags? 1 bag. And a loaf of pumpkin bread. How many loaves? 1. If you look at this equation, we have x plus y equals 11. So this x means 1 trail plus 1 loaf, and that equals $11. That's where they got that equation from. Then we have the equation 3x plus 2y equals 24. So if I look at the next part, it says 3 bags of trail mix. Well, isn't that 3 bags of trail mix? And this says 2 loaves of pumpkin bread. That's that right there. And it has a cost of $24. So that's where they got those equations from. Awesome. So how can we approach this? Well, in order to graph that and find out where they intersect, don't I have to solve for y first? I've got to have it in y equals mx plus b form. So x plus y equals 11. So I need to get y by itself, so I'm going to subtract x from both sides. So I get y equals negative x plus 11. Okay, then I have this other equation of 3x plus 2y equals 24. So I still want the y to be by itself, so I have to get rid of the 3x. So the opposite of adding 3x is to subtract 3x. So I'm going to do that. I bring down my 2y. Remember, this went away. I have negative 3x plus 24. I need it just to be y, not 2y, but just y. So I'm going to divide by 2. I'm going to divide all those by 2. Okay, 2 doesn't go into 3 evenly, so we're going to write it as negative 3 over 2x plus 2 goes into 24 12 times. Okay, so now we have that. Now we need to graph it. Why they would not put a graph here for us? That's ridiculous. I wonder if I can insert a graph. I don't think I can. That's okay. We're gonna try and do one. It's not gonna be pretty, but that's okay. So the x's we were talking about up here, the x's, x is the cost of a bag of trail mix. So cost of trail mix. Okay, and then y's were the cost of a loaf of pumpkin bread. Okay, there we go. Now, 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, that one was really close. 4, still kind of close. 5. 1, 2, 3, 4, 5. So that's 15. 1, 2, oh, trying to get them about the same distance. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so now we're going to graph this. So the first one has a slope of -1, and it has a y-intercept of 11. So I'm going to come up here to 11. Hey. And I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Okay. Down 1 over, it's going to be here at 11. Okay. Then my other line is going to be a slope of -3 over 2, and it has 12 as my b value. I'm going to come here. So I'm going to go down 3. So 1, 2, 3 over 1, 2. Is that where they run into each other? Is right there. So that's when, down 2, no, down 3. 1, 2, 3. So that's at the point 9. So then that's when x is, or y is 9, not x. The y value is 9. And we went over 2, so that's 1, 2. So that means the x value is at 2. Okay. And that will get me, this will get down to right here. Okay, so now let's see if it actually works. So I have the point, or the equation, x plus y equals 11. If I plug in 2 for x, and 9 for y. Will those equal each other? 11 equals 11. Okay, so it works for that one. Now let's plug it into 3x plus 2y equals 24. I'm going to replace the x with 2, the y with 9, and see if that works. So that's 6 plus 18. Does that equal 24? It does. Okay, but yes, it's the 0.29, but what did we say 2 stood for? Are the x values. The x values stood for the cost of trail mix. So $2 for a bag of trail mix. Okay, my 9 is up here. It's the cost of a loaf of pumpkin bread. So it's $9 for a bag, not a bag, a loaf of pumpkin bread. And this would be your answer. Okay, so Chloe skated an average speed of 10 miles per hour, while Avery skated an average speed of 5 miles per hour. They skated a total of 20 miles in 2 hours and 2.5 hours. The situation can be represented by x plus y equals 2.5 and 10x plus 5y equals 20. Okay. So how many hours did they go? Oh, sorry. Before I do that, we're going to do this. X represents the number of hours Chloe skated. And then Y represents the number of hours Avery skated. Okay. Do we know we know that the total hours is 2.5. So what they've done is they took the amount of hours Chloe skated, plus the amount of hours that Avery skated, and it has to come out to 2.5 hours. Then what they did for the other equation, they know that Chloe skated 10 miles per hour. We know that Avery skated 5 miles per hour, and they went a total of 20 miles. So now I have to do just like I did before, and they have to equal, it has to be y equals. So I'm going to subtract x from this side, and I get y equals negative x plus 2.5. Then on this other one, I'm going to subtract 10x from both sides. I'm going to get 5y equals negative 10x plus 20. Divide both sides by 5. And I get negative 2x plus 4. Okay. So the slope on this one is negative 2. The y-intercept on this one is 4. Over here, the slope is negative 1, and the y-intercept is 2.5. I really want... I wonder... You know what I could do? I could do this. Ignore what I mean, don't ignore it, but Oh, that's not going to work. Never mind. Never mind. I wonder... grid. There we go. No. Oh. I want this one right here. Okay. So let's go back to that one real quick and see what our equations were. Negative x 2.5. So y equals negative 2 point, no. Negative x negative x plus 2.5, and the other equation, y equals negative 2x plus 4. Negative 2x plus 4. So we are going to use we're just going to use black or purple or whatever color. We're going to use this right here. That was horrible. It is not working for me. There we go. And this right here. Okay, so I'm starting with 2.5. So I'm going to go up by 0.5. So this is going to be 1. This is 2. This is 3. So I'm going to go to 2.5 right here. And then I'm going to go down 1 over 1. So this is going to be 1. This is going to be 2. So if I go down 1, and over 1, I'm going to go here. Down 1, over 1. Come on. I'd be right here. Down 1, over 1, I would be right here. Okay. Then I'm going to do this other one. I'm going to go up to 4. So 4 would have been here. I'm going to go down 2. So 1, 2, over 1. Down 1, 2, over 1. So they run into each other at this point right here. So that's the point, 0.5, comma, 2. So 0.52. So 0.52 is where they run into each other. So the X stands for how many hours Chloe skated. So Chloe skated half hour. Okay. Avery skated 2 hours.